Hello. Today we are moving on to some problem solving with quadratics and using all of the skills that we learned to solve some real world problems. In this note, you'll see it's a large note. It's going to be broken down into 3 videos, kind of separating the types of questions that we're solving. So you can kind of categorize them that way. So this first thing here is just a big review of what we know, which I think we probably already did together. If not, we will be doing that together in class. This is a really important page to understand. When we are doing problem solving with quadratics, we need to remember what the main features represent. Okay, so if something asks you for the best, highest, most, least, anything like that, that's asking you to find the vertex. And remember that the vertex is negative b over 2a is how you find the x value. However, if it's asking you when does the ball hit the ground or when is it at water level, when is the area equal to 25, when it's asking you to solve an equation, that's when you use quadratic formula. So if you're trying to maximize something, find the best, that's vertex. If you're trying to solve an equation, that's quadratic formula. And if they're asking you a starting point, so like where was the rocket when it was launched, how high off the ground, that is the y-intercept. So those are the key things to consider when you're being asked for y-intercept, vertex, or solving an equation. And those are the 3 major methods we'll be using throughout. Now, we also need to remember about how to convert back and forth between these forms, which again, I believe we did together already. So we will start with factored form. Start with how to actually create equations, because that is what's going to be different with problem solving, is that some of the equations you're going to actually have to create from scratch instead of them being given to you. So you can create an equation in factored form, or you can create it in vertex form. And from either of those forms, it can be converted to standard form. So this is a quick review to remember how to do that. So factored form works best if you know the x-intercepts and at least one other point on the curve. So the first thing is to identify the x-intercepts. So in this example, they are 5 and -3. Sub the intercepts into this equation. So y equals a. So it would be x minus 5, x plus 3. Then you sub in another known value for x, y. So since there's a y-intercept of 6, that's the coordinate 0, 6. So you're going to sub in 6 equals a, 0 minus 5, 0 plus 3. Then you solve for a by isolating it. So 6 equals a, -5 times 3. So a is that's -15. So you get 6 over -15, which simplifies to -2 over 5, and then you write the final relation. Okay, so vertex form works best if you're given the vertex and at least one other coordinate. So in this case, our vertex is h is 3 and k is 7. Okay, so we sub that into vertex form. Then we sub in another known value, so 5, 1. So 1 equals a, bracket 5 minus 3, all squared plus 7. So 1 equals a, 2 squared plus 7. Oh, I took up too much room. I should have left more space. Okay, here, I'll finish this over here. So 1 equals 4a plus 7. So 4a equals -6. So a is -3 over 2. So your equation would be this. Okay, if you need the equation in standard form, you must first find it in vertex or factored form and then convert it. So now we get on to height versus time, or height versus horizontal distance. So this is the path of projectiles. So things like rockets, kicking a ball, throwing a stone, anything like that. So in this case, the zeros represent when the object, so the stone, the ball, the rocket, hits the ground. So I should say when or at what distance. It depends what the independent variable is. So if it's height versus time, it would be when, but if it's height versus horizontal distance, it would be at what distance. The x value of the vertex represents the time or distance when object reaches its max or min height, usually max. And the y value of the vertex represents the max or the min height. Okay, so let's do this first example. This formula can be used to model the height of a toy rocket, where h is the height above the ground at t seconds. Graph the path of this rocket. So for this, we would like to have the vertex, the y-intercept, its partner, and the zeros. So let's start with finding the vertex. So we take note that this equation is in standard form. So to find the x value of the vertex, or in this case, the t value, we do negative b, so negative 60 divided by 2a. 2 times negative 4.9. And if you put that into your calculator, you get 6.12. So that means after 6.12 seconds, this max height will occur. Then to find the height, you put 6.12 into the equation, which in this case would give you 186.53. So that's our vertex. Now we find our zeros. So again, because this is in standard form, we don't want to factor that. We can use quadratic formula to find the zeros. So t equals negative 60 plus or minus the square root of 60 squared minus 4 times minus 4.9 times 3. That's a 3. All over 2 times negative 4.9. So if you carry this through, you get two answers. T equals, sorry, actually you just get one admissible answer. The other one is inadmissible. Okay, we can also see that the h-intercept is 0, 3. And another partner of this would be 12.243, using our axis of symmetry to find another point. So we can create our height versus time axes. We only need the positive quadrant because height and time both have to be positive. So we know we hit the ground at 12.30 seconds. So we need to get just slightly above 12. So I went up just by 1. So 1, 2, 3, 4, etc. But for my height, I know I needed to get up to 186 meters. So I went up by 20. So 20, 40, 60, 80, 100, 120. Okay, so now we can plot our parabola. So 0, 3 then, because this is 20, it's basically down there. And then 2, 4, 6, just over 6, and 186 is about there. And our other, we're at 12.30, so 2, 4, 6, 8, 10, 12. It's hard to show exactly. If you want more of an idea of how this curve looks, you can just plug in other t values. If you want to have a more accurate representation, like you could put in 4, you can put in 10. But that is the basic, where this is t and this is h. So then, because we've already graphed it, we can answer the rest of these questions relatively easily. So how long would the rocket take to fall to the Earth? Well, we know that this point is 12.300. So we can say that it takes, or it is in the air for 12.3 seconds. Okay. What is the maximum height of the rocket and when does it occur? So the max of 186.5 meters occurs at 6.12 seconds. Over what time interval is the height of the toy rocket greater than 150 meters? Okay, so let's understand this graphically first. So greater than 150 meters, so here's 100 and, well, that's 140. So here's 150. So there's going to be 2 times where it hits 150 meters. So it's between these 2 times where the parabola is greater than 150 meters. So we need to find this x value or t value and this t value and just find out how far apart they are in order to solve this problem. So we need to find for what t, at what time is the height 150 meters. So that is setting the equation equal to 150. So this is our equation for height in terms of time. And we want to know at what time is the height equal to 150 meters. So we need to solve this equation. So in order to solve a quadratic equation, you need to move everything to one side, and then you use quadratic formula. So I move the 150 to the other side. Okay, and now I use quadratic formula. So my A is negative 4.9, my B is 60, and my C is negative 147. I use this version where it equals 0, and I put it into quadratic formula. Notice that I'm using t here instead of x, since that is the value of the independent variable. So this is almost like finding the zeros, but our C value is different because we're solving a different equation. Okay, so we get here that T is equal to 3.39 and T is equal to 8.86. So this means that it is at 150 meters at 3.39 seconds on the way up and at 8.86 seconds on the way down. So to find how long it's above 150, we subtract the 2. So we get 5.47 seconds. So therefore, it's above 150 meters for approximately 5.5 seconds. So 5.5 seconds. Sorry, I was just trying to pause that because it doesn't work. Okay, so now we'll go to consecutive numbers. Okay, so I believe I just have one. Yes, just one consecutive number problem. So consecutive numbers are numbers that are one after the other. So if I started with the number 5, the next consecutive numbers would be 6, 7, 8, 9, etc. So if I start with the number x, the next number would just be x plus 1, then x plus 2, x plus 3, etc. But this question talks about consecutive even numbers. So let's say I started at 10. The next one would be 12, then 14, then 16, etc. So if I start with x, my next consecutive even number is x plus 2, then x plus 4, etc. So the product, this means multiplication, of 2 consecutive even numbers is 5, 6, 2, 4. What are those 2 numbers? So we're going to say let x represent the first number. So we're going to say x times, now the next consecutive even number is x plus 2. And we know that that product is equal to 5, 6, 2, 4. Oops. So we are just solving this equation. For what x's is this true? So to do that, we can distribute x through. And this is perhaps easier for you to see that this is a quadratic equation. So to solve a quadratic equation, again, you move everything over to one side and then use quadratic formula. Okay, so now you use quadratic formula with your a, b, and c value. So my a value is 1. My c value is minus 5, 6, 2, 4. So you get x is equal to 74, or x is equal to negative 76. Now your first gut reaction might to think that this is inadmissible, but this actually gives you two sets of solutions. So the first one, where x is 74, means that the two numbers are 74 and 76. If you check in your calculator, 74 times 76 equals 5624. But for the x is equal to negative 76, that means that negative 76 is the first number, and then the next consecutive even number is negative 74, right? If we're going up the integer scale. So negative 76 times negative 74 is also positive 5,624. So these are actually two sets of solutions. This is one solution, where those are the two numbers, and this is the other solution. So there are two solutions. All right, so that gives you an introduction to height and time problems, as well as consecutive number problems. So thanks for watching. Hope you learned lots. And it will not stop.